Welcome back to Clever Coding. Today I'm really excited to teach you the sixth lesson of the ongoing C++ programming series. Once again, highlight out three major reasons why you should prefer Clever Coding over the others. First of all, it's absolutely free. Second, designed for beginners with zero or somewhat experience. And I got your hands, man. I'm gonna hold your hands through this entire course. And third, it is 24/7, 365 solutions to your problems along with some awesome projects we're going to be making during these courses. So I'm excited. I hope you are excited. Let the fun begin. So now we're going to open up our IDE. And we're going to continue from the last video. So hash include input of a stream. And then standard main, and then all this necessary stuff we've already discussed. Okay, so last video had for loops. So today we're going to talk about loops inside other loops. So they're basically called nested loops. So for instance, if I have a regular for loop, like for instance 1 I is less than 10 and I plus plus, and I just console output and I and end line. And if I save this code and let me go back and I go over here C++, and then over here I write code 10. And what do you think will be output? What will be the output? So there's from 1i all the way to 10. So basically it's going to be, as you guessed, 1 all the way to 9. So let's see it. 1 all the way to 9. Awesome. What if I tell you that we could not only numbers, but we could also print whatever I want? Like, for instance, I could print asterisks. So if I save this and execute it using this, oh, you see those 9 stars that are going down. Now, some beginners also use this nested for loop to make a triangle of stars. So we're going to do this today. So for instance, if I have for int j is equal to 1, and then I say, well, j less than 10, and then j plus plus, and then I put another curly braces inside, and I just see out j and a space, nothing else. And over here I'm just gonna print out end line. So now if I save this, let's see what will happen out. I know this is not the right thing what I want right now, but look at this. It's a square of so many, from 1 all the way to 9, and I want to tell you how this all actually happened. So first of all, we start from the outside for loop, and in this one, it's starting from I as 1, the iteration variable, and it's going till 10, but in the first case it's 1. So when it's 1, it goes till here, this other for loop that's inside nested, and it's saying j is equal to 1, and then j is less than 10, which is correct. So it's going to print out 1, and then it's going to increment plus plus plus, as you see over here, as 2, and then after that it's going to check again if j2 is less than 10, and yes it is. So it's going to print out 2, and then another space, and then it's going to print out 3, 4, 5, 6, 7, 8, 9. Once it's 9, it turns 10, and it's always 10 is equal to 10, not less than. So it breaks out of this loop, and then it goes to the new line, and then after the new line it goes and increments its I once more to 2, and now it's gonna print out 1, and then 2, 3, 4, 5, 6, 7, 8, 9. Again, it's going to do an end line, and so on. So after looping all the way to 9, when I reaches to 10, it's going to break out of the loop, and then the program will terminate. So you're going to see a grid, a 9 by 9 grid. When I execute this, compile and run, you're going to see a 9 by 9, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was awesome, and we could do a lot of varieties with these. And now, after doing this, now we're gonna have a project that we have to make. So the project, what we're basically making, a simple project, is that we're making a multiplication table, and also addition table, and also a subtraction table, and also a division table using for loops. Okay, it's not going to be nested. And this program is really efficient. So must watch this. So first of all, for instance, if we want the number of the table, so we basically say num, and for instance I say num over here, and then I basically want to say the stopping number. So I could basically say a number where you want to stop the table in. Like for instance, like you basically commonly say 10. So basically I say stop. So I could like print out cout number, oops, number of table, and then I could say cout stopping number, and then I say cin, and then I say stop. Okay, you can name you can name any kind of variable name you want. I like this because it's more mnemonic for me and it's more understandable. Okay, so basically how I'm gonna implement the first one, which is the addition one. So I'm gonna say for addition, ADITION. Okay, that's how you spell it. I'm gonna make an inline too, \n escape sequence. Okay, so for not another int I is equal to from 1, like always, I less than equal to the stop variable, what we said, and incrementing all the time. And over here we're gonna have console output and the number. For instance, like we have I, and then we have a space, and then what we have is the addition sign. So we could say plus, and then we have another space, and we say equal sign, and then we could say over here we're gonna say I, which is 1 plus number, not space over here, but the number we want. Like for instance, if we say num, so basically you say num over here, and then we say I plus num, and every time it's gonna do that, it's gonna give it in a new line. So after that, it's gonna do that. So for the sake of simplicity, I'm gonna save this and I'm gonna execute this to check if it's correct for us. Okay, for instance, number of table, I say 2, and I say the stopping number as 10. So you're going to see the first case as 1 plus 2 is equal to 3, 2 plus 2 is equal to 4. It's starting from 1 all the way to 10. Okay, it's nice, but there's a little weird space. I want to remove that space. And that space is this one over here. So I just cross that out. And now let's check if the compiler executes it really properly. And let's see if 2, 10. So now it's better, 1, and it goes all the way to 10, and that's really cool. So now we're gonna do others, like for addition, and then for subtraction, for multiplication and division. So I'm just basically gonna do a shortcut method. What I basically like, I do copy, control V to copy and paste. So control V I'm doing. Okay, so now we have 4 of these, and so I'm basically gonna have a new line over here. I'm saying \n, and for subtraction I could say over here, so subtraction, and it's going all the way over there, and instead of plus it's going to be minus, and instead of this it's just going to be minus over here. And that was easy. So now next one is console output, and then a \n, and once again there's no semicolon. Okay, now after that subtraction we have multiplication, asterisk symbol, and we just have an asterisk symbol right here, and that was easy. Now the last one, another console output \n, and this is going to be for division. So I could say division, and we'll put that division, that / and over here as well. Okay, once again I remember that for division the numbers are in integers, so basically the decimal part won't show. So for that solution I'll make this as a double type, which reserves 8 bytes to make the output more precise. So I think we are ready for our output. So save this and project, execute, compile, and run. Let's see our output. So basically if I say number of table, I say 2, and I stopping number as 10, you could see over here in the console screen, first of all, it's addition. So it goes 1, 2, 3 all the way, and it's correct. Then 1 minus, okay, 2, 3, 4, and it's subtracting, and it's all the way correct. And now multiplication, 2, 3, 4, 8, 9, 10. Awesome. And then division, we could say 1 divided by 2, which is 0.5. Awesome. Now that you could tell how powerful computers are. So we could make it even better by giving it a hard number that humans might have trouble calculating. So basically, if I say number of table 22 and I say stop at 101, oh my god, look at that. That's insane. So check this out. First of all, we could also put labels, you know, like console output, and we could say addition, and then it's adding all the way until it reaches 101, and then all the way until it reaches 101, and all the way until it reaches 101, all the way until it reaches 101. Awesome. Enter key to I press any key to exit out. Okay, so now after this, that was awesome. Hope you like this program. Alright, so another thing I wanted to bring up is that we missed a data type that I should have discussed earlier, but I'm discussing it now. And it's called the char data type. And this is very precise in C++. So I'm going to include another header file called cstring. And this char was basically introduced in the C language, which was the older version of C++, where there was no strings, and strings came up in C++ where you used to have a sequence of characters, and that would be easier for us to manipulate. But long time before the discovery of C++, there was no strings, and we had to write strings character by character, and it was really hard, but they also introduced this in C++, so it's like a mesh of all. So to declare a character data type, we write the keyword char, and then after that we make any kind of identifier like ci did, and then equal to single quotes, not double quotes, single, because double quotes indicates strings and single quotes indicates characters in C++. So if I say single quotes q, and then I give a semicolon, and I say print it out, console out, C and end line, and if I save this, compile and execute. Okay, there's a return. Oh, there's no semicolon over here. Oopsies. Execute, compile and execute. All right, Q you have, and now you could see like it's like a foolish, childish thing that we just did. But I'll tell you, this is really important to know. And the next video where we're gonna deal with is arrays, and you're gonna see a lot of benefits using characters. Because it's more okay. And what characters takes, and I want to discuss one thing else, is that the character, the char, for instance, if I say not single quotes, for instance like h, and I say cout, console output, and I say size of, and I want to see how much the character takes. And the thing is, the character takes only 1 byte in the memory. So if I compile and run this, you're gonna see 1 byte that is reserved in the memory. So characters take 1 byte, and every character will take 1 byte. And now you can't like write a string like your name or something like your address. For that you'll need a string. And we'll discuss all of this later in the next video. Hope you guys tune in, and we'll see you in the next one.